This video is just an alternate way of finding the area of a sector, and you do so using proportions. The calculations all work out to be exactly the same as the previous posted video, but I kind of like the way you have to think through these problems a little bit more. So a proportion that we can set up would relate the central angle, in this case 52, over the whole circle. So our proportion is really a proportion of a part over the whole, and this time it's degrees over degrees, but since it's the same units, those units would cancel. And we just have 52 over 360. So our part is our central angle. Our whole would be the whole 360 for the entire circle. Set that proportion equal to another part over whole. The area of the sector is the part, and the whole is the area of the circle. So 52 over 360 is equal to the area of the sector over the area of the circle. Well, we have enough information to find the area of the circle. It's pi r squared. 8 is the radius, so it's 64 pi. And that's the area of the sector, is the numerator. And now we just solve this proportion, and we would have the area of the sector is equal to 64 pi times 52 over 360. Now if you watched the previous video, you'll notice that this is the exact same values, and now it even looks like the equation that we set up in the previous video as well, which shouldn't be a surprise because it's all the same numbers. We should expect to see the same answer. It's just a different way of thinking about how to set it up, and I found that some students like to think about this proportions method instead of thinking of it as a formula, and I actually like the thinking on this one as well. The nice thing is it works exactly the same way for if you wanted to do the arc length. The same idea, 52 over 360, that's our proportion, part over whole. The part of the circle we're talking about is 52 degrees out of the entire 360, is equal to part over whole. We're trying to find an arc length, and the whole that we're comparing that to is the circumference. So we would be able to set up 52 over 360 is equal to the arc length over 2 pi r, 2 times pi times 8, so 16 pi. And then solve this proportion. The arc length is going to be equal to 52 over 360 times 16 pi. And that would be another way to find arc length, again using the idea of proportions. Part of the circle over the whole circle, part of the circumference over the whole circumference. So that's another way that you can find area of the sector or arc length using proportions.